Okay, you're in week 7, and this is the week where we're going to give you the midterm. So you'll get an email regarding that, and you should pay attention to that email and the schedule that we have set for you. What I recommend you do, though, is go back over weeks 1 through 6, both the notes, the embedded assignments that are within the notes, all the examples that we've done, and go over the web assign, right? You should also look at the review that we're presenting to you this week, and then you'll be ready to take that midterm. You should do very well on it. It shouldn't be a challenge for you if you've done what we've asked you to do. All right. So, what I'm going to do is I'm basically just going to, I'm not going to say quickly, but probably pretty quickly to go through this midterm review. So I'm going to switch to the whiteboard, and just give me a moment. Okay, we're at the midterm review, and we're going to talk about the first question. Let me just pull that to the side. And I'll just make it bigger for you. All right, so, explain each of the transformations here. So, like, if you look at, A, you should be able to understand what that does. It's a horizontal compression by a factor of 3. So that's something we've done in the past. If you look at B, it's a vertical expansion by a factor of 2, right? If you look at C, it's a horizontal expansion by a factor of 3. If you look at D, D is a vertical compression by a factor of 3, right? If you look at E, E is a reflection about the y-axis. If you look at F, F is going to be a reflection about the x-axis. We've covered this, and again, if you're looking at this and you're confused by that, you'd want to go back to that section on transformations. All right, let's go to the next question. That was pretty straightforward. They didn't ask you to graph or anything like that. But let's go to the next question, which is number 2. All right, pull it to the side. And let's take a look. So, what does it say? Solve for x. Certainly it's quadratic. The first thing I notice about this quadratic is that there's a fraction. It's what I would recommend is to multiply both sides by 2. No, it doesn't have to be done. But for a lot of students, it does make it easier to use a quadratic formula on it. So let me put this down. So if I multiply both sides by 2, I would get, whoops, sorry about that. I would get 2x squared plus x plus 2 equals 0. Well, the first thing I know about that is I'm not going to be able to factor it with my fingers. So I'm going to use a quadratic formula. So x equals, yes, you need to know the quadratic formula. What goes on the bottom? Twice the a. Well, a is 2, so twice the a is 4. What goes on top? The opposite of b, well, the b is 1. The opposite of b would be minus 1, plus or minus the root of, this is where a lot of students screw up. It's going to be b squared, which is 1, minus 4 times a times c. Well, 4 times 2 is 8. 8 times 2 is 16. I want to keep going forward. X will be equal to minus 1 plus or minus 1 minus 16 is minus 15. I'm starting to see that this is complex. So minus 1 plus or minus I root 15 over 4. If you're in WebAssign and they're asking you to write it in the a plus bi form, what you're going to do is write this down instead. X equals minus 1/4 plus or minus root 15 over 4i. With the understand the a is minus 1/4, that's this over here, and the b is actually 2 different numbers, plus or minus root 15 over 4. All right, look at the key. The key clearly has that answer down for you to look at. All right, I'm going to go to number 3 now. And again, they should be relatively simple questions. But again, this is just a partial review. It's not the full review. You need to go back, make sure and send all the material that we presented to you. So let's do this one over here now. And, certainly looking at it, I know it's a rational inequality. And the way we do this is we compare them to 0. So I want to get this thing compared to 0 first off. The way I'm going to do that is subtract x minus 1 over x minus 2 from both sides. All right, that's my first step. My next step, one term completely factored. This may take work. LCD is x plus 3x minus 2. What do you get here? X plus 2, x minus 2, minus x minus 1 times x plus 3. All right, let me keep moving forward. And the bottom's already factored. And what do you get on top? You get x squared minus 4. That was easy. Minus, well, the second one's going to be x squared. And then you get 3 minus 1, which is plus 2x. And you get minus 3. I'm going to keep moving forward. And yeah, the work is important. And what do you get? X squared minus x squared is nothing. Well, you get minus 2x then. I see that. And let's see, minus 4 minus 3 is minus 1. All right. I'm going to attempt to factor the top now. I'm going to pull out a minus 1. And what do you get? 1 plus 2x over x plus 3, x minus 2. All right, now I'm ready to do my number line. And what goes on the number line? All the zeros. I'm going to do one at a time. Certainly minus 3 as a 0 on the bottom. That's where it changes sign. The other 0 on the bottom is at 2. This should be put down in the proper order. The 0 on top is actually minus 1/2. And I'll put that right here. All right, the first thing I want to discuss is when is it equal to 0? Only at minus 1/2. It is not equal to 0 at 2 because you have a division by 0, and it's not equal to 0 at minus 3 because you have a division by 0. Now take test points, and what I mean by that, you can take a value, for example, a value between minus 1/2 and 2. A good value to choose here would be 0. And what are you going to do? Plug it in. I'm going to write that down for you as I plug it in. I'm going to test 0. You don't need to write this down, though. What do you get on top? You would get a negative number if you plug 0 in. What do you get on bottom? A positive times a negative. And overall, this would be positive. Now, I hope you realize that, positive numbers are not less than 0. So this would not get shaded in. Right? I'm going to take another test value. And the test value I want to pick is over here. I'm going to pick the test point x equals 3. And what do you get on top? Well, you get negative on top. And what do you get on bottom? Positive, positive. Overall be a negative number. I hope you realize that negative numbers are less than 0. So I would shade this in now. All right, let's keep moving. And let's take a point between minus 3 and minus 1/2. I'd say, a good test point here would be x equals minus 1. Plug it in. What do you get? Well, on top you get, plug in minus 1, you get minus 1 times minus 1, positive number. You get a positive times a negative. Overall, it's negative. All right. So, I know this interval here is negative here. Negative numbers are, of course, less than 0. So I would shade this in now. All right. I'm going to take a test point over here. It's a good test point over here. I don't know, x equals, this is a test point, by the way, minus 4 maybe. What do you get on top? A positive number. You can plug in minus 4 yourself. On bottom, you get a negative times a negative. Overall, it's positive. All right, so that's not less than 0. So I'm ready to answer it, and certainly we'll look at the k after we answer it. What's the answer going to be? Looking at my number line, it's minus 3 up to minus 1/2, inclusive, union 2 off to infinity. All right, whoops. Again, I'm going to recommend you look at the answer key. And what I mean by that is you're looking at this thing over here to make sure you have it. All right, the work is not being shown though. We have the answer. All right, so that's not bad. At number 3, I can go to number 4 now. And again, hopefully these are not difficult questions for you, that you're quite familiar with it. Unfortunately, if you're not doing much work, you're probably not going to be familiar with anything that's being presented to you. And that's not going to bode well in the future. So I'm going to solve this. It's a polynomial of degree 6, and I'm going to have to factor it at some point. But my first goal is to get it compared to 0. So 5x6, I'm going to subtract 3x4 from both sides. I'm going to factor it now. x4 would come out, and what are you left off with? 5x squared minus 3. All right, what I'm going to do is I'm going to list the zeros in the problem. And what I mean by that is there's going to be, although they're repeated, they're pretty easy to come up with. For example, x4 becomes 0 when x is 0. All right, I'm going to put this on the side. 5x squared minus 3 becomes 0. Well, I'll use square root rule. 5x squared equals 3. Whoops. X squared equals 3/5, or x equals plus or minus the root of 3/5. And I'll put this over here. I know for some students, these are terribly difficult numbers, right? My claim about this over here is you should have some idea about the R integers to the left and right of those numbers if you want to pick them out. So I'm going to talk about a test point over here. And the test point I want to pick up over here is I want to pick a number above the root of 3/5. I'm going to say a good test point over there would be 1. Whoops. Give me 1 second there. I seem to have lost that. You know what I did? Maybe I want to, oh yeah, I'm sorry. I hit the next page button. So the test point, a good test point to choose over here would be x equals 1. All right, let's go through it carefully. And, looking at it, I'm going to say if you put a 1 there, the first factor, x4, would be positive. That's not so bad. It's always positive, actually. And the second factor, well, if I look at that, it would be 5 minus 3, which is a positive number. Now, what's a positive times a positive is a positive. I'll put this down. All right. I'm going to pick a test point. Again, I'm going easy first. I'm going to go over here, test point, and I'm going to say x equals minus 1 will be a good test point here. Plug it in. What do you get? Well, minus 1 to the 4th power is still positive. And the second factor is going to be, will be 5 minus 3. That's still positive. What do you get over there? A positive number. All right. I realize some students are struggling now, and they're saying, I don't know what number to choose. I would say really stick with something super, super, super simple. Like you could choose, 0.00001. That is definitely between 0 and the root of 3/5. All right. If you plug it in, this is a test point, by the way. What would you get over there? Positive. And what do you have there? Negative. And what certainly, if you square that times 5, it's certainly going to be a number much smaller than 3. And a number smaller than 3 minus 3 is a negative number. So this is negative over here. Are negative numbers less than 0? Of course they are. Whoops, let me get my black. All right, there's some symmetry about this, but let's say you don't notice that. Pick a test point. What's a good test point over here? I would say x equals minus 0.0000001. What's that going to give you? Well, if you plug it in x4, it's still positive. And over there, it's still going to be negative. Again, why is that? If you square that number and multiply it by 5, it's certainly less than 3. And a number less than 3 minus 3 is definitely a negative number. I know it's negative, and are negative numbers less than 0? Of course they are. So what's my answer over here? They're not asking about the 0. They're just asking about when it's less than 0. It's pretty simple. What's it going to be? I'll write the intervals down for you. Minus root 3/5, comma, 0, union 0 up to root 3/5. That's the answer we're looking at over there. Okay, I just want to briefly discuss. Some students get annoyed by that number, root 3/5, because your teachers told you not to write that down in Math 100. Let me put this over here for you. You could have done that and multiply top and bottom by root 5. And what do you get? Root 15 over 5. If you prefer that number, that's fine. It's up to you what you want to write down. All right, let's go to the next one. And I guess I just did number 4, right? Let me do number 5. All right, then we'll do number 6 next. All right, so let's take a look. And I don't know where I put this somewhere, right? Gonna find some nice clean spot in a piece of paper. And I'll put this over here and blow it up a little bit. Push this up. And let's start. All right, what they want me to do is find the x and y intercepts of the relationship. And I'll put this down for you. The relationship is x squared minus xy plus 8y equals 9. And to find an x-intercept, what I have to do is just set y equal to 0, which is fairly simple to do. What would this give me? X squared equals 9. So I'd actually get 2 points. And why is that? X could be plus or minus 3. So what are the x-intercepts? 3, 0, or minus 3 comma 0. So I got the x-intercepts. Let's do the y-intercept now. We'll look at the key later. What do you do there? Set x equal to 0. Well, if you did that, what would you get? Let me take a look at that. What are you going to get? You're going to get 8y is equal to 9, where y is 9/8. Let me write that down for you. So the y-intercept is going to be x is 0, and the y is 9/8. I'm going to circle around that, indicating I'm done. And let's see if we got it right. And certainly it says the y-intercept is 0, 9, 8. I got that right. And the x-intercepts are, plus or minus 3, 0. That's certainly written down. All right, let's go to 6. Last problem on that page there. And I noticed that the answer is probably on the next page, right? So we'll put this one down. All right. Whoops. And let me see if I can pull that somewhere. And I'll put this, let me get rid of some of this stuff over here. I'll put this right here. And sorry about that. Okay. So certainly if you're reading that, you don't know what you're reading, my impression, if you don't know what you're reading, go back and study, right? Because everything should be familiar to you. All right. So they say, given that f of t equals 3t squared, what they want you to do is determine the net change from t equals 4. And write this down for you. To t equals 4 plus h. All right. So let's write this down. F of t is going to be 3t squared. So, if t is equal to 4, and then they have t equals 4 plus h, and they want to know what the change is, they're asking for the delta. All right, they're asking for the delta f now. All right, so I'm going to write it down. And what is it going to be? It's going to be f of 4 plus h minus f of 4. All right, let's see if we can do that. All right, so what do you get over here? Well, what does f do to the function? 3 times, I'm sorry, not the function, but the argument, 3 times the argument squared. We'll do that in a second. Minus 3 times the argument squared. Well, let's do that. This is 3. Well, I'm going to do 4 plus h squared, which is 16, plus 8h, plus h squared, minus 3 times 16. All right, let me just, I got to move things around here. Whoops. That's not moving anything around, is it? I'll move it around that way. Let me get this over here again. All right, I'm going to look at it. So let's take a look. What are you going to get? 3 times 16 is 48, plus 24, plus 3h squared, minus, 3 times 16 is 48. What do you get over there? 24 plus 3h squared. If you prefer, you can write it as 3h squared plus 24. I'm sorry, 24h. I'm sorry. I just noticed that. All right, which is important. Like when you're web design, if you notice something, you get 2 chances to notice it. I'm going to look at the key now, though. And so why do you look at the key? I want to see if you got it right. So I got that, and I got the net change. This is the net change. What else have they asked for is the average rate of change. So it's going to be the delta f over the delta t in this case over here. So what's delta f? We just did it. It's 3h squared plus 24h over the delta t. And the delta t, I'll put this over here for you, is going to be 4 plus h upper minus lower, which is 4. And delta t is going to be just h, right? I'll put this over here. And what do you get here? Yeah, I expect to do some arithmetic and some simple algebra. It would be 3h plus 24. Okay. I want to make sure you look at the key and you're seeing those answers in the key. All right. Let's go to number 7 now, the next page. And we'll take a look at number 7 now. Pull it on the side. And these questions, I mean, a lot of them, there really should be deja vu all over again. All right. Find the domain of this problem over here. It doesn't look too bad. I'm going to say, initially what we like to do is we just say all the real numbers. Whoops, all the real numbers are coming in. Let me get my eraser out. So all the real numbers. However, I know looking at the bottom, x cannot be -1 because I have division with 0. The other thing I'm looking at, that even root problem, and I know this. I know that 6 minus x squared must be greater than or equal to 0. Let's see if we can do that by factoring it. And I'm going to see if I can do that. And again, if I can't, I get quadratic form, which I hope I don't have to go. I'm going to say x and x. That's not so bad. I'm going to say 3 and 2. That's not so bad. 3 times 2 is 6. I'm kind of looking at it. I'm still, whatever I write down, I'm going to check it. 3 times 2 is 6. That works. Minus 3 plus 2 is -1x. That works. You do get minus x squared. Put my number line down. And what do I put in my number line? Numbers. And what number to put down? -3. That's where the first factor becomes 0. And the other factor would be at 2. Oh, they're easy because shade them in, they become zeros. And I'm getting much better at this sign analysis business. And what's a good number between -3 and 2 would be 0. If you plug 0 in, you get a positive number. And it was certainly, I say positive, definitely positive is greater than 0. And again, without any sense of bias, I'll go beyond 2, 3. If you plug 3 in, you get positive times a negative, which is a negative number. That's not greater than 0. If you went below -3, like -4, you plugged it in, you would get a negative times a positive, which is a negative number. So I'm ready to talk about what the number line would look like, all right, for this problem over here. I do know that there are some numbers that are allowed in. So I'm going to say definitely between -3 and 2 is allowed in. But there's a number that I can't let in, and it's over here. Now, where's -1? It's on the interval. Right? But all the numbers in between these are let in except -1. Now, if -1 says, why can't I come in? It's because there's a division by 0. So let's write down the intervals, what we're going to go for. So -3, we'll look at the answer in a second. -1, union, -1, up to 2. Look at the key. Make sure you're looking at the same answer. And if you're not, you know there's got to be something wrong. All right, let's go to the next one up, which is going to be number 8. Okay, and I'm just going to pull it to the side. Whoops, I made a mistake there. Pull this one to the side, get rid of all this stuff over here. And let's talk about one at a time. And certainly when I'm talking about one thing at a time, I'm going to do like, A first. I'm going to look at the answer key. Whoops. And after I do 8, I'll look at the answer key. So we got f of x equals 3 minus 5x. They give me the domain, and the domain is going to be from -infinity to infinity. You should have a good idea just looking at that. It's a line, and its range is going to be -infinity to infinity. Now, someone says, why would you need that? I want to write down the inverse, and I want to know the domain and range of it. Well, that's really simple because both of these guys, whether you rotate around or not, is still going to be -infinity to infinity. Let me point out what I'm doing over here. Domain becomes range, and range becomes domain. Okay, what's my goal here, though, is to find the inverse. So let's go through that. So I'm going to take this over here, and I'm going to change f of x to y. And I'm going to change x and y together, interchange them. It's going to be 3 minus 5y, and then solve for y. 5y, 3 minus x, and then I'm going to divide through by 5. And what are you going to get? Y equals 3/5. Let's do 3 minus x over 5. All right, I'm going to write that down for you over here, and then I'll box the answer for you. So it's going to be 3 minus x over 5, or if you prefer, 3/5 minus 1/5 of an x. Okay. Again, my recommendation to you is to look at the key, of course, to make sure you're looking at that answer. And of course you're looking at that answer. It'd be ridiculous to say otherwise. All right, so I'm going to do letter B now, and it's a deja vu to me. I'll tell you why. It's the exact same problem that we've given you in class. I can remember that. And that's really the odd thing. Most of your exams here are going to be really almost identical questions to what you've seen before. And it's often, I hate to say this, sometimes it's comical. As students show up to exam and they say, where did you get these questions? It's really kind of communicates that very little effort has been put into the study time. And if you're studying these questions, this looks very familiar to you, all right? I'm almost positive we did this in the examples. But if not, it's so similar as almost to be, almost simple to do. So let's write this down. F of x is equal to x minus 5. We have an answer key too to look at. And what I'm going to do over here is, they give me the domain of it. And the domain, I'll just write down minus infinity to minus 1/3. Union minus 1/3 to infinity. And I kind of remember we did this problem. We kind of graphed it out and stuff. And we came up with the range of this guy over here. And the range was minus infinity up to 1/3. Union 1/3 up to infinity. All right. Okay. So question is, what are we going to do now? I'm going to put down F inverse. What I do know, though, is I do know the domain of it, and I do know the range of it immediately. And repeat what we're doing over here. Domain becomes range. Range becomes domain. I'm just going to write those down pretty quickly. And this one's minus infinity to minus 1/3. Union minus 1/3. Whoops. To infinity. I'm going to do the work now. And the work is going to be, I change f of x to y. I'm going to interchange the roles of x and y. I'm going to try to solve it for y. And the way I do it, clear the fraction, 3xy plus x, y minus 5. X plus 5 equals y minus 3xy. X plus 5, y, 1 minus 3x, and then y, and that's pretty simple. Y would be equal to x plus 5 over 1 minus 3x. So let me see if I can put that down now. And not that I want to, it's x plus 5 over 1 minus 3x, right? I'm going to look at the answer key. And again, it's important. You also look at that answer key and make sense out of it if you can. Let's take a look. I'm looking at it. Yeah, I got the same answer. X plus 5, 1 minus 3x. That's good news. All right, let's go to the next one. And that's going to be letter C, right? It's Deja Vu again. I'll put it over here. It's really Deja Vu. And what is it? F of x. Domain is going to be from 0 to 4. The range, you should have some idea what this looks like. Certainly, if you just, it's related to a circle, then a semicircle, and then a quarter of a circle. It looks sort of like this over here. So its range would be 0 to 4. Let me see if I did that right. 16 minus x squared, 0 to 4. And yeah, I think I did it right. So what am I going to do here? And I'm going to be careful here. So let's write this down. Let me see if I did that right. 0 to 4. 16 minus x squared. That's a circle. Positive. Yeah, I did it right. Let's put this down, F inverse. All right. I know the domain and range. It couldn't be simpler, could it? I'll remind you what it is. Domain becomes range, and range becomes domain. Well, that's pretty simple. 0, 4, 0, 4. And let me just go through the work. Y equals f of x, and this is going to be 16 minus x squared. Interchange x and y. Solve for y. I'm squaring both sides, by the way. Y squared would be 16 minus x squared. I got trouble now. Y is equal to plus or minus the square root of 16 minus x squared. I want to point out to you, though, although it seems like trouble to you, look back over here, and it's really important you know about this thing over here. What am I looking at? What's it pumping back? Positive numbers. So what do I got over here? It's going to be the root of. Here's an example of a function whose inverse is the function itself. That seems to make sense, by the way. If you looked at a line like this, and you were to rotate that graph through that line, it would be the same exact graph. All right? All right, let's go to, I guess I got to go to letter D now, right? Let's take a look at D. And yeah, D's not, it's really deja vu all over again, isn't it? Let me just make sure you know what I mean by that. And I'll just select D again. Pull on the side. Let me put this over here. Pull this up a little bit. Give me 1 second here. Damn, I'm going on my fingers. Oh, there it goes. I'm sorry. My fingers are cold. So let's take a look. And let's put it down. And certainly it's really deja vu all over again to me. And write this down for you. F of x equals 5 minus the root x minus 2. They give me the domain. The domain is going to be from 2 to infinity. The range of this thing, and again, I want to point out, we've done this before. You may recall, we drew a picture of it. We know it starts at 2. At 2 would be the number 5. This is 5, and this is 2. And what's happening to this thing is looking like this over here. So the range of it's going to be, goes off to minus infinity in that direction, certainly goes down forever, and then it tops out at 5. All right. Now, someone says, is that important to get? It is, because that's going to really determine the tone of my inverse. And let's go through this again, domain and range. And domain becomes range, and range becomes domain. And I'm ready to write those down now. So domain is going to be minus infinity up to 5, and the range is going to be from 2 to infinity. All right, let's go through the work now. So y equals 5 minus the square root of x minus 2. Interchange x and y. Well, I'm going to try to solve for y if I can. Square both sides, you get y minus 2. If you square the other side, you get 25 minus 10x plus x squared. And y would equal 27 minus 10x plus x squared. Let's write that down. 27 minus 10x plus x squared. Okay, let's look at the answer key. And again, I know I said a lot to you. You really should be looking at an answer key. And what do you see in F inverse? 27 minus 10x. I'm seeing that plus x squared. I'm seeing it. And I'm seeing the domain of minus infinity to 5. Looking good. All right. Let's go to the last one, which I believe was letter E, right? Oh, boy, I got to copy E now. And let me pull it over here. And let's take a look. All right, letter A. It's a parabola. It's pretty simple. And I'll write this down for you. F of x equals x squared minus 1. They give me the domain, and the domain is going to be from minus infinity up to 0. Now, if you looked at a picture of this thing over here, which is, I'm not going to say terribly important to draw it out, but it might be, the picture of x squared minus 1 would look, certainly below 0 would look like this over here. All right. That's the way it looks, right up like this over here. All right. So I got the range of it. And what's the range of it going to be? Well, it looks like it bottoms out at minus 1 and then goes off to infinity. So I can write F inverse down now. I may not know what it is, but I certainly know the domain and range of it. And let me just emphasize again, domain becomes range and range becomes domain. And I'm ready to write those down now. All right, let's go through it. Y equals x squared minus 1. Interchange x and y. And make some attempt to solve for y. So what are you going to get? Y squared, x plus 1. And that means y would equal plus or minus the square root of x plus 1. And I got troubles again. So what are your troubles over here? I really have to look at what the range of the problem is. It's going off to minus infinity. So it really kind of tells me it's got to be the negative. So I'll put this over here, minus the root of x plus 1. Let me circle it. I'm circling the answer, by the way. And I want to see if I got it right. And what do they say? Yeah, I got the same answer, which is good news. All right, let's go to number 9 now. And I got to go to the next page, don't I? And let's put number 9 down. Number 9 says state the domain and range. Could be easier. I like easy questions. So domain is all real numbers. Range is a little more complicated. I want to tell you why it's more complicated. I need a picture of it. And so the way I'm going to do the pictures, I'm going to graph this. I know it's a parabola. I know it's vertex. I'll write this down for you. I can read it because it's in standard form. Its vertex is going to be 2, 5. So we did that 2 and then 5 up. And what kind of parabola do we have here? One that opens upwards like this over here. So now I know the range, all right, looking at it. I guess I have my picture. And again, range or what's being pumped back. Well, what's the lowest value it could be is 5, and it goes off forever in the upward direction, by the way. So domain and range. Look at your answer key, and I'm seeing those answers over there. All right, let's go to number 10. And let me take a look at number 10 here. Ooh, another familiar question. Right, what I mean by it's really familiar. I mean, it's almost like I've done these before. And you should realize, yeah, you've done these before too. All right, pull that aside over there and get this here. Let me get my eraser out. Got an artifact over here. Get rid of it. And let me blow this thing up here. Find two real numbers whose difference is 100. Well, I'm going to say x and y are real numbers. And I'm going to say x minus y. That's the difference between numbers is 100. Again, x and y are real numbers. Okay. And then it goes on and says whose product is a minimum. Right? What does it mean? It means x times y is a minimum. I'm minimizing something. Unfortunately, this has something to do with what we study, which is parabolas. So I'm going to write down, I really want to minimize a function f of x. I want to minimize this. And again, parabolas we minimize, right? So x times, what's y? X minus 100 would be equal to y. Let me write that down for you. What do you get over here? Well, it's a parabola. If you want to look at that, x squared minus 100x. I'm going to draw the picture of the parabola for you. And what's that going to be? Well, it's got a 0 at 0 and a 0 at 100. It's got an axis symmetry at 50. That's x equals 50, by the way. And the parabola looks like this over here. All right. So you certainly can get the vertex there over there. Would that be agreed? All right. So let's see if we did that right. Oh, I made a mistake. I'm sorry. I made a mistake. And I got to correct that. And I'm not thinking when I do. The reason I made a mistake is I realized there's a minimum there. It's a maximum. It couldn't be right. I got a wrong answer there. So I'm going to rethink. I can't say that. That's crazy. Sorry about that. Let's go back over this again. I have 0 and 0. And this parabola opens upwards. This is a 0 there, and this is 100 over here. The axis symmetry, it's still x equals 50. And you're going to get a vertex over here. This is where the vertex is going to be. It opens upwards. If you want, you can compute that. In 1 second. Okay, so if you want, you can compute that number. Not important, by the way. It looks like this over here. If you want to compute that number, the vertex would be at 50, comma, minus 50 squared. All right. What was our question, though? Find two numbers. I already know one. X is 50. I know x is 50. What's the y, though? What's the y value? Well, if you look at it, the y value would have to be minus 50. All right, the y would have to be minus 50 in this case over here. All right, what are the two numbers? The two numbers are 50 and minus 50. What are you going to do? Look at the answer key. Make sure that you're staring at that answer. And you are. It says 50 or minus 50. All right, let's go to number 11 now. A little more complicated, isn't it? And let me see if I can do that for you, number 11. It's a bigger question, though, isn't it? But I got to be honest with you. It's deja vu all over again. It really is deja vu. All right. Now, so what do you mean deja vu? We've done the problem before. If you're not seeing these problems, it's like, not recognizing people you should recognize. All right. Now, it says given that x equals 1 minus I is a root of this, I do want to point out if it's a root of it, and this is really important information, this is a polynomial. It's degree 4. It will have 4 roots. It's a real coefficient polynomial. If it's a real coefficient polynomial, these roots here, the complex roots, must occur in conjugate pair. So I'm going to say right from the get-go, if this is truthful, and if x equals 1 minus I is a root, the other root would be 1 plus I. All right, there's going to be 4 roots, by the way. Now, by the way, A, they say verify that that's a root and it's conjugate. So what do you have to do? You have to verify that f of 1 minus I is 0, and you have to verify that f1 plus I is also equal to 0. There's 2 things to verify there. I'm going to do one for you, all right? Now, someone says, which one do you want to do? It really doesn't matter, but I'm going to do this one over here, all right? And then I'll leave this thing for you to do. If you need help with this, come by during office hours. So if you need help, come by during office hours, and I'll be more than happy to go through that with you. I want to do f of 1 plus I, though. And what would that give you? Well, again, you might say, I can't do it. Of course you can. So it's 1 plus I to the 4th power minus 2 times 1 plus I cubed. I think you probably remember me doing this before, right? Minus 3 times 1 plus I squared plus 10, 1 plus I minus 10. All right, let's start, easy. I really mean that. I'm going to factor it. I'm going to factor out 1 plus I squared. And what do you get? 1 plus I squared minus 2, 1 plus I minus 3 plus, all right, I just did these 3 over here. Now it's plus 10 plus 10I minus 10. Well, what's nice about this right from the get-go? These things disappear. Let's keep going through it, though. What's 1 plus I squared? It's 1 plus 2I plus I squared. Well, you know what? I squared is minus 1, so it's 1 minus 1 is none, so it's just 2I. I'm going to write that down now. Get my eraser out. Okay, I'll put a square bracket there for you. 2I minus 2 minus 2I minus 3 plus 10I. Well, some work over here, isn't there? Now I'll put out what the work is going to be. And I notice that these things disappeared. And so I have 2I, and then I have minus 2 minus roots minus 5. So that would give me minus 10I. Plus 10I would equal to 0. And I need to verify that. And again, what you're left to do as an exercise, see if you can do this one. And I think you can. It's not that bad. It really isn't. All right, let's see if we can do B now. B says since x equals 1 minus I and 1 plus I are roots, we know that these 2 things are factors. We know it. What do they want you to do? They want you to expand it. All right. Now, someone says, how do you know they're factors? If these are roots, all I'm doing is 1 minus those numbers. So, 1 minus 1 plus I would be 1 minus 1 minus I. Whoops, I think I copied something wrong over here because I just noticed it. And the other one would be 1 minus 1 plus I. Oh, pretty good. Then I'm going to expand it though. And I'm going to go through the expansion. And yeah, it's a lot of work. It's x squared. I'm using the distributive property multiplication. Minus x. Minus xi. Ooh, a lot of work. Minus x. Plus 1. Let's see, plus I. Let's see, plus xi. Or ix, depending. Minus I. Let's see, minus I squared. Oh boy, it's going to be some work, isn't it? X squared. Oh, I'll get my red pen out. These disappear, right? These disappear. All right. And 1, and this would be actually 1 plus 1, which is 2 now. And you get minus 2x. All right. So they asked me to do that. I do want to recommend that you look at the answer key to make sure that what you say is correct is correct. So again, I want to point out in the answer key, you want to look at B's answer. It's in the blue area and see if you got that. And certainly you're looking at that. All right. Now let's go to C. What does C say? Long divide. All right. So I'm going to write that down for you. And I'm going to take x squared minus 2x plus 2. And they want me to long divide into the polynomial. What's polynomial? X4 minus 2x cubed minus 3x squared plus 10x minus 10. Okay, certainly we know things are going to work out. And so how do you know going to work out? Yeah, we have theorems for this. I mean, if we said we're roots, this is going to give me a division. It's going to be really nice. And that division going to produce a zero remainder. Let's go through it. And what times x squared x squared would be x squared. It's going to work out really nicely. And if it doesn't, we made a mistake somewhere. And what do you get over there? Minus 2x cubed. Then we get plus 2x squared. We're going to subtract. Yeah, you would need to have the long divide, right? And then minus 5, right? What do you have there? Minus 5x squared plus 10x minus 10, remainder 0. So I'm comfortable I got the division done. Right? Again, I would recommend you look at the answer key and get that. All right, let's go to D. And I'm just going to go back and read it to you. It says factor x squared minus 5. I'll do that. And again, in math, you say you couldn't do it, but now you're in 119, you can. It's x minus root 5, x plus root 5. And why is that? X squared minus 5 equals 0. X squared equals 5. X equals plus or minus root 5. All right. They're the roots. So the factor can be, x minus that number. And x minus root 5 is x minus root 5. And x minus root 5 is x plus root 5. All right. So we did this factorization. And last but not least, let's take a look at the next question. That was D. And I look at the answer, and the answer is good. It says verify the factorization is correct. And it's work. So I'll write that down for you. So it's going to be E. They want me to verify that x minus 1 plus I times x minus 1 minus I times x minus root 5, x plus root 5 is what they said it is. Well, let's go through that. They said it's f of x. And if I did that, I want to point out we did these before. I might as well use that again, right? I hope you remember we did it before. That would turn out to be pretty simple over there. And this one would turn out to be this over here. I'm going to multiply it out now. And what do you get? You get x4 minus, I'm using distributive multiplication, by the way, and I'm distributing in this direction because it's easier for me to do that. Minus 2x cubed plus 2x squared. And then you get minus 5x squared plus 10x minus 10. Let me combine these terms together. X4 minus 2x cubed minus 3x squared plus 10x minus 10. And really what I want to do is just emphasize, you really look back to make sure that that's what you said it is. And is it true? Is it really f of x? Well, if you look back at f of x, it's x4 minus 2x cubed minus 3x squared plus 10x minus 10. And again, you should look back in your notes to make sure that's the case. All right. Last but not least, is list all the roots. Well, we've been through this over and over again. There's going to be four roots. This is letter F now, and I can remember what the roots are. We just did it. Plus or minus root 5. And the other roots are going to be 1 plus or minus I. So let's write these down as a listing. Root 5 minus root 5, 1 plus I, and 1 minus I as a listing. All right. Look at the answer key. Make sure you're staring at that. And of course, you're staring at that. All right. That finishes out the review for you. So the review is done. Review is done. Again, I want to emphasize if you have trouble and you need to reach out, sometimes it just means giving you advice about what you need to do, which you need to put a considerable time and effort in mastering the material that we presented to you. And that does take time and effort, by the way. This isn't something that happens quickly. But again, if you need help, something resolved, please reach out and we can discuss it. Thank you.